Could this be Voyager 1's biggest discovery for the year? Voyager 1 has spent nearly 5 decades traversing space and relaying incredible feedback to Earth, with each discovery more intriguing than the last. However, a recent revelation has caused a major divide among scientists as they examine the data. Now, the long-awaited moment of clarity has arrived as renowned astrophysicist Neil deGrasse Tyson unveils the shocking findings in space. Join us as we explore how Voyager 1 detected 500 unknown objects passing through space and discover Tyson's thoughts on this astounding discovery. On June 30, 1908, a stony asteroid crashed into Earth, striking a city in Siberia, Russia. The powerful impact of this event resulted in the flattening of approximately 2,000 square kilometers. The profound magnitude of this event reverberated worldwide, causing a global shockwave. Subsequent research led to the publication of The Unspoken Alliance Between Astrophysics and the Military by Neil deGrasse Tyson, wherein he highlighted the convergence of scientific exploration and national security, advocating for increased investment in space exploration to safeguard our planet. This extraordinary work revolutionized public awareness surrounding the importance of space exploration. In a surprising turn of events, NASA's spacecraft Voyager 1 has just detected 500 unknown objects passing by in space, leaving scientists perplexed. Neil deGrasse Tyson, the world-renowned astrophysicist, has once again emerged to provide much-needed clarity. However, as scientists delved into the mystery of these 500 unidentified objects, they stumbled upon an astonishing revelation about Voyager 1 itself. But before we look into that revelation, let's first familiarize ourselves with the remarkable Voyager 1 spacecraft. Voyager 1, the gallant space explorer, has currently traveled over an astounding 14.5 billion miles away from Earth. The speed at which the spacecraft travels through space is truly astounding, covering a distance approximately 3.6 times the space between the Earth and the Sun each year. But there's more to the interstellar probe than just its speed, longevity, and distance from Earth. Voyager has sent several groundbreaking revelations to us, like the recent 500 unknown objects it detected out there in the vastness of space. These are strange celestial objects that we've never seen or identified before. We'll get into that big reveal in just a moment, but there's a question that's probably on your mind right now. How can a spacecraft that was launched way back in 1977 still be functioning and delivering such groundbreaking information? Well, the answer lies in the incredible engineering and foresight that went into Voyager 1's design. One of the key secrets to Voyager's longevity is its dual redundant computer systems. Each Voyager spacecraft, including Voyager 1, was equipped with 2 sets of command computer subsystems: the Flight Data Subsystems, FDS, and the Altitude and Articulation Control Subsystems, AACS. This redundancy served as a crucial safeguard, allowing seamless transitions between systems and the ability to activate dormant computer components, thus extending their lifespan. The computer systems aboard Voyager 1 and its twin, Voyager 2, were organized as a distributed system with 3 dual redundant pairs of computers. This redundancy ensured that even if one system failed, the other could take over, preventing mission-critical failures. To make the best use of limited power resources, Voyager's instruments relied on hardwired logic. This means that the computer systems were designed with simplified hardwired circuits to ensure that they could function within the constraints of power budgets and time limitations during the spacecraft's development. But power management is key in sustaining Voyager 1's operational integrity. The spacecraft's distance from the Sun, where it can harness solar energy, poses a significant challenge. To maximize power efficiency, engineers had to come up with innovative ways to conserve and optimize power usage. The power management strategy employed by this remarkable man-made probe is truly extraordinary. One critical aspect of power management involves selectively powering down non-essential systems. Engineers meticulously evaluate which components or subsystems are not vital for the primary mission objectives. For example, heaters associated with certain scientific instruments have been deactivated. These heaters were originally meant to maintain the instruments at specific temperatures for optimal performance. By turning them off, power consumption is significantly reduced, thereby extending the spacecraft's overall lifespan. This decision to power down non-essential systems is not taken lightly. It requires a careful evaluation of the trade-offs between power conservation and the scientific objectives of the mission. Engineers collaborate closely with scientists to ensure that deactivating specific systems doesn't compromise the quality and availability of scientific data. The goal is to strike a balance that maximizes power efficiency while maintaining essential functionality. But that's not all. Voyager 1's power management strategies also adapt to the changing conditions of its environment. As the spacecraft journeys farther from the Sun, the available solar energy decreases. To compensate for this, Voyager 1 adjusts its power usage accordingly. This adaptive approach ensures that the available power resources are efficiently allocated to support critical operations and data transmission. This is where it gets really interesting. Over the years, there have been ongoing technical advancements and improvements in power management techniques, allowing engineers to refine and optimize the power systems of the Voyager probes. These enhancements include more efficient power distribution, improved battery charging methods, and advancements in power regulation and control. Thanks to these meticulous power management strategies, engineers have successfully extended Voyager 1's operational lifespan, enabling it to continue its remarkable scientific journey through the cosmos. Considering that the spacecraft was initially designed to last for just 5 years, the fact that it's still sending back information almost 50 years later is nothing short of astonishing. It underscores the dedication and skill of the scientists and engineers who have worked tirelessly to keep Voyager 1 operational. However, even with all this careful planning and engineering, the depths of deep space remain unpredictable. Don't go anywhere because a major discovery is coming. What did Voyager 1 discover that shocked scientists? While there are some general expectations of what Voyager 1 might encounter, such as meteoroids, asteroids, and space rocks, there's always the potential for unexpected surprises. One such unexpected twist in the Voyager 1 journey was the spacecraft's claim of detecting 500 mysterious objects. This revelation caused quite a stir and raised significant concerns among the researchers working on the project. These mysterious signals and anomalies in the data came as a complete surprise. Voyager 1 started transmitting telemetry data back to Earth, but the readings were unusual and there was no clear explanation for what was happening. The researchers labeled this phenomenon an anomaly. Yet, despite the erroneous transmission, Voyager 1 continued to respond to commands from Mission Control, though with a slight delay in communication. This was a perplexing situation, and it deepened the mystery. What was particularly puzzling about this anomaly was that it did not trigger Voyager 1's onboard fault protection systems. These systems are designed to activate when anomalies are detected, putting the spacecraft into a safe mode that allows engineers to investigate and diagnose the issue. In this case, however, Voyager 1 continued its operations without entering safe mode, adding to the intrigue. After an exhaustive investigation, the anomaly was traced back to the Altitude and Articulation Control Subsystem, AACS. The AACS plays a critical role in precisely orienting the spacecraft and controlling its movements. It was discovered that the AACS had been sending telemetry data through an onboard computer that had ceased functioning years ago. This outdated computer, which should not have been involved in data processing, had somehow become entangled in the telemetry transmission process, leading to the corruption of the information being sent back to Earth. The challenge now was to fix this anomaly and determine whether there were indeed 500 unknown objects out there. The solution involved instructing the AACS to redirect telemetry data to the appropriate functioning computer. This fix was considered low risk and was successfully executed. However, addressing this anomaly was not without its unique set of challenges. One of the most significant obstacles faced by the mission team was the substantial time delay in communication. Voyager 1 is now located approximately 14.6 billion miles away from Earth, a truly staggering distance. As a result, it takes a considerable amount of time for radio signals to travel through this vast expanse. When the mission team at NASA's Deep Space Network, DSN, sends a command to Voyager 1, it travels as a radio signal at the speed of light. The DSN is an extensive network of colossal radio antennas strategically positioned across the globe. Its primary function is to establish two-way communication between Earth and deep space missions. The DSN collaborates with various space agencies worldwide, creating a unified effort to explore and investigate the mysteries of space. The DSN comprises 3 deep space communication facilities situated approximately 120 degrees apart: Goldstone in California's Mojave Desert, Madrid in Spain, and Canberra in Australia. This strategic placement ensures continuous coverage and observation of spacecraft as the Earth rotates, making the DSN the largest and most advanced scientific telecommunication system worldwide. The communication with Voyager 1 occurs through radio waves, utilizing the colossal antennas at these DSN stations. When transmitting data from the spacecraft to Earth, a frequency of either 2.3 GHz or 8.4 GHz is used. On the flip side, when sending signals from Earth to Voyager 1, a frequency of 2.1 GHz is employed. Despite the incredible speed of light, even at this speed it takes approximately 22 hours for a command to reach the spacecraft. This time delay adds a layer of complexity to communicating with Voyager 1. The mission team must carefully plan and execute commands, taking into account the anticipated response time. Any errors or issues can result in additional delays and complications. During the anomaly investigation, this time delay posed a unique challenge. It meant that diagnostic and troubleshooting processes were significantly prolonged. Commands had to be carefully crafted, keeping in mind the 22-hour waiting period before a response could be received. Receiving any confirmation or response from Voyager 1, but here's the incredible part: despite the significant time delay, every message transmitted to Voyager 1 was not just adding to the information, it was a vital part of the mission. The time delay may limit real-time control and interaction, but it doesn't diminish the significance of the communication. Each message was a crucial piece of the puzzle in resolving the anomaly. In the end, the anomaly was fixed at its source, and the faulty computer was shut down. Voyager 1, the majestic spacecraft, could then continue on its incredible journey through the vastness of space, sending back valuable data and insights to Earth. Voyager 1, the majestic. Why is Voyager 1's discoveries a big deal? Now that we know the previous malfunction of the space probe has been resolved, let's see the remarkable accomplishments of the spaceship when it had no problems. The primary objective of the incredible spacecraft, launched on September 5, 1977, was to explore our solar system, but its journey extended beyond that initial purpose. Voyager 1's story began with a unique twist. Months before reaching Jupiter, it started transmitting images of the gas giant. These early images, showcasing Jupiter's magnificent swirling clouds and the iconic Great Red Spot, were an instant hit at NASA's Jet Propulsion Laboratory. But this was just the prelude to a journey that would redefine space exploration. What truly set the stage for the Voyager's groundbreaking observations was the discovery of active volcanoes on Jupiter's moon Io. This unassuming moon, slightly larger than Earth's moon, held an astonishing secret. It was the most volcanically active body in our entire solar system. Voyager 1's instruments detected peculiar signals from Io, and the vivid images it captured unveiled a world of towering volcanic plumes and a surface scarred by the ejection of volcanic material. Among these, Pele, one of Io's most prominent volcanoes, has erupted as high as 30 times the elevation of Mount Everest, blanketing an area nearly the size of France. The mysteries of our solar system were unfolding before our eyes. Before the recent mind-bending discovery of 500 unknown objects passing by in space, the twin Voyagers had been wowing us since their launch. One of their most surprising findings was the existence of Jupiter's rings. These delicate rings, while faint, added an aura of mystique to the already enigmatic gas giant. Voyager 1's twin probe added another piece to the puzzle by revealing that Europa, one of Jupiter's 53 named moons, was encased in an icy shell over 60 miles thick. This challenged our previous assumptions about the nature of distant celestial bodies and ignited a new wave of curiosity about the potential habitability of icy moons. But there's more to the story. As the Voyagers bid farewell to Jupiter, they received a crucial farewell gift: a gravity assist. This gravitational boost, similar to a cosmic slingshot, propelled them towards Saturn. Without it, they'd have been stuck in the Sun's gravitational grip, unable to venture further into space. Voyager 1's path took it close to Saturn's intriguing moon Titan. Shrouded in an orange hazy atmosphere, Titan's mystery stirred scientists' curiosity, prompting in-depth studies of its complex chemistry. Voyager 1 then set its course northward, leaving the plane of the planets and commencing a journey beyond the solar system. Amidst all these discoveries and marvels, there was one individual who played a pivotal role in extending the missions beyond their initial goals: the renowned astronomer Carl Sagan. As a member of the Voyager mission's imaging team, Sagan passionately advocated for one final set of images before shutting down the spacecraft's cameras. These images, he believed, would be a parting gift to humanity, offering a final view of our home planet from the depths of space. Sagan's persistence paid off, and on Valentine's Day in 1990, Voyager 1 turned its camera back toward the solar system. The result was a series of 60 images, one of which became iconic: the pale blue dot. Taken from a distance of 3.8 billion miles, it remains the farthest image of our planet ever recorded. Earth appears as a minuscule pale blue speck, barely discernible amidst the vast cosmic backdrop. The Voyager 1 showcases an extraordinary tale of exploration, perseverance, and longevity. Even after 4 decades, the brave explorer continues to transmit invaluable data from the farthest corners of our cosmic neighborhood. However, what's truly surprising is their reliance on old-fashioned technology: 8-track tapes. Yes, you heard it right. These remarkable probes still utilize 8-track tapes. It stands as a testament to the brilliance of the mission's architects that these robust tapes have stood the test of time. You may wonder why 8-track tapes were chosen. At the time of their launch, digital storage as we know it today was in its infancy. They needed a reliable and durable data storage system, and 8-track tapes fit the requirements perfectly. What's more incredible is that the data stored on these tapes isn't your run-of-the-mill content. It's scientific data of immeasurable importance about the outer planets, moons, and interstellar space. These tapes hold the key to understanding some of the most profound mysteries of the universe. Neil deGrasse Tyson. Why is Neil deGrasse Tyson so excited about this recent discovery, and what does it have to do with aliens? Alright, let's talk about Neil deGrasse Tyson, the popular astrophysicist, prolific author, and the charming host of Star Talk on National Geographic. He's basically the guy who makes astrophysics cool. The internet's favorite astrophysicist was born on October 5, 1958, in New York City. Tyson's academic journey led him to Harvard University, where he studied physics. He later earned his doctorate in astrophysics from Columbia University, solidifying his expertise in the field.